We are now going to start working on the hyperbola problems. So for this test number 1 review, the first hyperbola problem is number 10. For the following equation of hyperbola, determine the center, vertices, and the foci. Excuse me. Then sketch the graph. So here's the equation of n hyperbola. And this is information they want us to figure out and sketch the graph. I'm sort of surprised they did not ask for the equations of the asymptotes. Let me check the other problems. So there's one down here where they ask for the asymptotes. I will probably, we'll have to see. Maybe we get to the end. We'll see about trying to find the equation of these asymptotes. So, excuse me. All right. So the first thing we want to do is, here's our equation. I'm going to grab the formula sheet. I first want to see if this equation is in the standard form. Hyperbola equations, once again, there are two of them. They look a lot like the ellipse equation. The only difference is the ellipse equation, the two fractions are added, and hyperbola, the two are subtracted. So you notice in the denominator, the a squared is always the positive fraction. So if you remember ellipses, a squared is always the bigger number. Well, with hyperbolas, a squared is always the positive fraction. But the other things are the same. One side has to be 1. All you can have are numbers and bottom of the fractions. So I look at this. First thing I notice is I don't have a fraction here. Well, if it makes it easier for you to understand, I can always turn it into a fraction by putting it over 1. So I've got a 1 over here on this side. I've got 2 fraction numbers in the bottom. So actually this equation looks like it's in standard form. So for hyperbolas, once again, hyperbolas, we can have up or down hyperbolas or left and right. So hyperbolas have 2 parts to them. So what you do is the positive term, so this is going to be a squared, and this is going to be b squared. Now, since the x is the positive term above the a squared, when that's the case, that means this is going to be a left or right hyperbola. I just think of the x-axis as the horizontal axis. So this is going to be a left-right hyperbola. Now, if I can figure out the center, the vertices, and the foci, then we can sketch it. So let's write down the standard equation for the left or right parabola. So it's x minus h squared over a squared minus y minus k quantity squared over b squared equals 1. So from comparing the standard equation to our equation, we can find h and k, which is the center of the hyperbola, and we can find a and b. And as we figure these things out, we'll start to sketch, and you can see how we come up with the sketch of the hyperbola. So let's do the center first. The center is going to be hk. So once again, h is with x. So you do the same thing we've done before. When I'm trying to figure out h, I take this whole number, including the sign in front. So I think of it as -2. Becomes the opposite when I put it here. So it's just 2. The k is whatever is with the y I grab this +3, but I change the sign to determine the value of k. So this is the center of the hyperbola, 2 minus 3. I can graph it 2 minus 3. So that's like the center of the hyperbola. Now, a squared is underneath the x squared. So a squared equals 9, which means a equals 3. B squared is underneath the y squared. Looks like b squared is 1. Therefore, b is 1. Now, the way we sketch hyperbolas is a is the distance you move in the direction of the hyperbola. Since this is a left or right, from the center, I'm going to move 3 to the right and then 3 to the left. So 1, 2, 3, 1, 2, 3. There's my distance A in the direction of the hyperbola. B, I'm going to move that in the other direction. So in this case, up and down. From the center, move up 1 and down 1. Now what happens is when you have these 4 points around the center, I'm going to create a rectangle where these 4 points are going to be the center of the 4 sides of the rectangle. So let me just draw it. It could be pretty clear to see. So I've made a rectangle that contains these 4 points. And then what you do is I'm going to draw these diagonal lines, and it's going to go through the opposite corners of the rectangle and the center. So sometimes I have a ruler handy. I'll just use that so I don't get off too much. If you don't have a ruler on the test, that's fine, but just since I've got one here. These are actually called the asymptotes. I do the same thing with the other 2 corners, and it goes through the center. And then we can actually sketch in the hyperbola since it's a left or right. I go here from this point, and what's going to happen is each side of my hyperbola is going to go up right next to my asymptote. It's never going to cross it, but it's just going to get close to it, sort of like this. And the same thing for the other side. So there's what the hyperbola should look like. So actually, we've got the sketch. We've already determined the center. The vertices, these are called the vertices. So I can figure those out. Looks like we're at 5, -3, and -1, -3. And the foci. Now, for hyperbolas, the foci are 2 points inside each side of the hyperbola in here somewhere. And the distance from the center to the foci is, once again, going to be called C. Now, for hyperbolas, the formula that relates A, B, and C is C squared equals A squared plus B squared. Since I know A squared and B squared, this gives me a way to calculate C. So for the foci, I'm going to use this equation. A squared is 9. B squared is 1. So C squared is 10. So if I take the square root of both sides, the foci is actually square root of 10. And just to get an idea of what that number is, it's approximately 3.2. So if I just wanted to graph it, looks like 1, 2, 3. Looks like the foci are just past the vertices. Now, if I want to write the point, what I do is, in this case, the center is 2. And then I either add the distance C or subtract the distance C. C is actually square root of 10, so I can say 2 plus or minus square root of 10. And then the y value doesn't change. It's always at -3. So this should be everything they asked for. So let me check. The center, 2 minus 3. Vertices, 5 minus 3, -1, -3. Foci, 2 plus or minus square root of 10 minus 3. Now, although they don't ask for it, let me just go ahead and do it because it may be on the exam. They probably should have asked for it. The equation for the asymptotes, I have 2 asymptotes, and those are these diagonal lines. These are straight lines. And if you remember, if I want to get the equation of a straight line, a lot of times I put it in the slope-intercept form. So I'm going to first take this asymptote. I need to find the slope and then the y-intercept, and then I'll have that equation. If you remember, when you have a graph, the way you find the slope is you can do rise over run. You pick 2 points on the line and you step off the rise and the run. Let me choose this point here, the center, and this corner of the box. So the rise is 1. Looks like the run is 3. Looks like the slope of this line is 1/3. So the equation of that asymptote so far is just 1/3 x plus b. Now I need to figure out what b is equal to. B is the y-intercept. Easiest way to do that is just to take a point from my line and plug it in. I'll just choose the center, right? Because the center point's on my line. The center is 2, -3. So I'll plug in 2 for x, -3 for y. So -3 for y, 2 for x. And this gives me a way to calculate what b should be. So this is 2/3. I got to subtract. Looks like b is going to be -3 minus 2/3. To combine these, this would be -9. Looks like -11/3. Wow, pretty ugly fraction. So basically, this one asymptote is going to be 1/3 x minus 11/3. Now the other asymptote, the slope, in this case, I won't even show it, but if you do it, you end up with, I'll call this, asymptote 1. Asymptote 2, if you calculate the slope, you'd end up with a -1/3. So therefore, I do the same thing. If I plug in the center point, because the center point, you notice, is on both asymptotes. I plug in the center point here to find b. Plug in -3 for y. And x of 2. Now, in this case, I'm going to have b equals -2/3 plus 3. Something like that. Looks like b should be 7/3. So the other asymptote is -1/3 x plus 7/3. Which is not quite right, I don't think. Because if I look, this y-intercept should be negative. So I must have made a oh, it's actually should be like this, sorry. So this is going to be -7/3, which sounds better. So -1/3 x minus 7/3. All right, asymptotes can be pretty messy, a lot of algebra, but I thought I would just do it. Although you weren't asked for it, so thankfully you wouldn't have to do that on this problem. All right, what's next? Number 11, find an equation for the hyperbola shown below. So now they give you a graph of an hyperbola, and they want you to find the equation. First thing I notice is this is a left or right hyperbola. So go to my formula sheet. The left or right hyperbola is the one where the x is positive. So the standard equation is going to be x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. So HK are the center. If I figure out A and B, then I've got the equation. So the center obviously is going to be right in the middle between the two parts of hyperbola, or you could think of it as between the two foci. It's pretty clear, I think. Looks like the center is at the origin. So actually the parentheses are going to go away. So now I just need to see if I figure out A and B. Well, A is the distance from the center to the vertices. So it looks like from 0 to 3. So A must be 3, A squared is 9. So now if I figure out B, then I've got what I need. Well, B, of course, is the up and down, but I have no idea. However, what I can do, I know the distance from the center to the foci is C. So C is actually going to be 5. Well, I need to know B. I know A and C, I need to know B. Well, what you can do, you can go to the little formula for hyperbolas. If I know C and A, then I can use this to determine what B is equal to. So it's a little bit of a convoluted way to find B, but that's so if C is 5, C squared is 25, A is 3, which A squared is 9. So B squared is 25 minus 9, 16. Looks like B is going to be 4. Although really I don't need B. What I really need is B squared, right? Because B squared is what the equation is. So now I basically have everything I need. H and K were 0. So it's going to be x squared over a squared. A squared is 9. Minus y squared over b squared, which is 16. And all that equals 1. So hopefully, if I check number 11, that's just going to be the answer. And it is correct. All right, two more problems. Number 12, find the equation of the hyperbola with the given conditions. They give the center, they give the vertices, they give the foci. So once again, I'm going to make a little sketch and graph this out. And once I graph it out, I can try and see what's going on and figure out everything I need. So let's go. Center 1, 1. So the vertices 1, 2, and 1, 0. So it's obviously, if these are the vertices, I know it's going to be an up or down hyperbola. Foci 1 minus 3 and 1, 5. So if this is an up or down hyperbola is this equation here. The y is positive. So this is my equation. It's going to be y minus k squared over a squared minus x minus h squared over b squared equals 1. Well, they gave me the center. So I know h and k. A is the distance from the center to the vertices, which I know is 1. Now, I don't know B, but just like the last problem, I know the distance C from the center to the foci. Looks like C is going to be 4. And from, here it is up here for hyperbolas, c squared equals a squared plus b squared. A squared is 1. I don't know b squared. C squared, c is 4, 16. So basically 16 equals 1 plus b squared, or b squared equals 15. Or b equals square root of 15. Well, I don't really need that. What I need is b squared. I don't really need to do this. So now I think I've got everything I need. So here, k is 1, y minus 1 squared over a squared. A is 1. A squared is just 1. As a matter of fact, this doesn't even need to be a fraction. It could just be y minus 1 squared minus x minus h. H is 1. B squared is 15 equals 1. So let's see if what the key says. Number 12, y minus 1 squared minus x minus 1 squared over 15 equals 1. Very good. Now the last one, they give you actually a specific problem where they give you the equation of the hyperbola and they want you to find the equations for the two asymptotes, the two lines that are asymptotes. So really to do this, I have to really sort of do the whole problem. So first of all, I look, and this is in a standard equation, and since the x is above the positive, this is going to be a left to right hyperbola. So it looks like the center HK is at the origin. A squared is 9, therefore A is 3. B squared is 4, therefore B is 2. So now what I'm going to do, let's go make a sketch. And once I make a sketch, then I can see about figuring out these asymptotes. So here's the center. I'm going to move A left and right since it's a left-right parabola. 1, 2, 3. Then 1, 2, 3. And B, I go up and down 2. So then make my rectangular box. Connect the corners in the center. So here are my two asymptotes. So for this one, the nice thing is the y-intercept goes through the origin. So the y-intercept, the B is 0. B is going to be 0. The slope here, I'm going to go from here to here, up 2 and over 3. Looks like the equation for this asymptote is y equals 2/3 x. For this one, now the slope is 2, -3, so the slope is -2/3 x. The y-intercept is still 0. So that's how you get the equations for the two asymptotes. All right, so those are the problems, the kinds of problems you're going to see on this first test.